All right, 28, 29, and 30. These are all flow charts similar to the one we just did in the previous problem. 28 we probably did together in class, so hopefully you were here that day and paid attention. It says, using physical characteristics, make a flow diagram that someone could use to separate cats, rats, and dogs. All right, so you'll notice we have three ways that this ends again. So we have three bottom boxes. Draw those right now. I'm going to say that these two came from this one, and this one came from our original question box. All right, so we need to end up with cats, rats, and dogs. We need to think of their physical characteristics. So I'm going to put a few over here. Dogs bark, cats meow, rats have hairless tails, long hair on some cats and dogs, so that was not very good. I guess it's both. I don't know. I can't think of any more. There are plenty more, but that's just off the top of my head, and 3 is plenty because I only need to ask 2 questions anyway. All right, so I'm going to say bark. That's my question. Does it bark? And I'm going to say yes here. I'm going to put a dog. That doesn't matter if I put a yes or a no over here. It just depends on how I ask the question. All right? Now, over here, I took, since the dog is eliminated, I'm left with rats and cats. I've already used that, so I need to think of another characteristic or question to ask that would separate these two now. All right, so I see meow and hairless tails. It wouldn't matter which one I asked, but I'm going to put a Y here, a no here. I'm going to say meow. I'm going to say yes, that meows. It's a cat. No, it does not. That is a rat. Now, the only way to get a flowchart wrong is to have the same thing on both sides. So if I wasn't thinking and I thought, oh, okay, cats meow, but rats and dogs don't. If I put dogs over here, that would be correct for this little part here. Okay, that would be correct for here, but we've already taken dogs out here. So you never have the same thing on both sides of a flowchart because we already eliminated that. Right, that's just one thing that some kids get confused sometimes. All right, 29, draw the apparatus when used to separate a mixture of white sand and sugar and remove both components. All right, think about the lab we did with filter papers and funnels. White sand will not go through filter paper, but water and sugar will. Simply something here. All right. Sugar plus water. Sand. That is all you would have to do. And I know that I'm giving you every answer. I don't know what I'm thinking, but oh well. All right, now 30. This is a piece of cake. There's a big long thing here. None of you ever read it. Please read it, but you'll notice you only have 2 things. So if you only need to separate them into 2 distinct piles, one's a yes, one's a no, you only have to ask 1 question. So you can ask it on any of these properties right here. It's super simple. Okay, 31 through 36. Identify the following changes as either a physical change or a chemical change. I'm not going to give you these answers, but the key is to remember that physical, if you have a physical change, its properties remain the same. All right, I'm going to read these real quick. So, no, it's not there. So the example, if I tear paper, it's still paper. All right, it's smaller, but size isn't a physical property. All right, so we've taken the paper, we've cut it in 2 pieces, but it still could be used to write on. We could still burn it. We could do all sorts of things to it because it's still paper. All right, so that's what you ask yourself. If I melt shortening, is it still shortening? I'm going to give you the answer even though I said it wouldn't. Yes, it's just hot shortening. Temperature isn't a physical or chemical property. It doesn't change what something is. It's just whether it's hot or cold. If I'm hot, I'm still Tom. If I'm cold, I'm still Tom. All right. So physical, if it's still the same properties. Chemical, it does not have the same properties. And mainly we're talking chemical properties. All right, so if I explode gunpowder, I no longer have a black powdery substance that I can carry around with a bullet. I have a very hot gas that is completely different in chemical properties. So we would say that this is a chemical. I don't know why I put a Y here. I just realized it is a P for physical. All right. Now down here, similar. These are now asking about the properties of whether it's a physical property or a chemical property, and this is a little bit different, so don't get confused. All right, a physical property we can observe without changing substance. That's a P. Goodness gracious, it's late. All right, so if I look at something and I say it's blue, did that all of a sudden change it to brown just by looking at it? The answer is no. So color, like here in 37, that is a physical property because to observe it, I don't have to change it. Chemical property, I do have to change it. So up here, the gunpowder, to determine its chemical properties, I had to light it on fire. I no longer have it. All right, so this gets a little bit tricky, but if you ever see the word reacts vigorously, so reacts, that must be a chemical property. There it reacts again. Everything else is going to be physical. All right, those are very simple. So the whole purpose of this section is to identify what we have. We have, let's see, properties, chemical or physical. We need to distinguish between the both of those. And we also have the changes, so a physical change or a chemical change. That's what you're supposed to learn from this particular section. Once again, not real difficult homework, but important and conceptual homework. All right. 2 through 86, maybe farther, I can't remember, but this is probably one of the harder sets of questions on this homework. And it's the first place where I start to introduce you to questions that are similar to the type of question that you see on the ACT. Having said that, that means that these questions actually don't require you to understand really anything about chemistry. They require you to have an understanding of scientific thinking and reasoning skills. All right, so let's look. It says, the table below lists some of the properties of the noble gases. All right, so all these gases here on the left are noble gases. That means that they are not very reactive and they reside in the far right column or family 8 on the periodic table. All right, 82 says, which of the listed properties does not increase as the atomic number increases? Okay, so notice, these are in order of ascending or getting bigger atomic number. Here's 2, here's 86. So this is saying which of these does not get bigger as we go down or as those atomic numbers get bigger. All right, so this is a piece of cake. Which one of these does not get bigger? 4 to 222, that's bigger. 0.18 to 9.91, that's bigger. This is tricky, but negative 269 to negative 62, that is actually an increase because we're talking about a negative value. So it must be specific heat, and that's obvious if we look. 5 going to 0.093. So it decreases as this increases. So we would say the specific heat, or D. All right, now that didn't require us to do anything that we've ever learned before. It just made us do some reasoning. All right, 83 sounds complicated, but it's not too bad. If air has a density of 1.3, how would you separate balloons filled with each of the above gases? All right, so here we have F, G, H, and I. We just need to read it. F says the neon balloon would rise and the kryptonite balloon would sink. All right, remember, anything less than 1.30 will go up or rise. Okay? More than 1.3 will go down or sink. You do have to remember the density. If you're above it, like a higher value, you'll go down, and if you're under it or a lesser value, you'll go up. All right, so neon, we're looking at neon. The neon balloon would rise and the krypton balloon. So we need to see this be less than 1.3. That's true. And krypton above. That's true. So right off the bat, we get letter F. If I remember right, there are two correct answers, F and one other one. You don't need to worry about the other one, but there is two if I remember right. I need to fix that. I just always forget. 84. If a mixture of all these gases were cooled, starting at room temperature, which one would liquefy first? All right, so we're going from room temperature, we're going down. So that's about 20 degrees Celsius, and we're going to cool it. All these are gases. We're going to cool the air until they come out. So the first one that should liquefy is the one closest in value to positive 20 degrees Celsius. So I look up here, here's the boiling point, because that's also the liquefaction point if I'm cooling it. All right, and I see that negative 62 is the closest, so we would say radon. All right, 85, 86, we continue to do that. 86 is very difficult. You have to do what it says, so multiply, divide, and times, and you're looking for one that has the same value or no change in the answer. You can estimate very easily.